Hello, I'm Vinod Ingale. We are discussing about the different types of walls used in industries. So here we can discuss about the basic construction and application of the walls used in many type of industries, and also see the animated videos of the walls. So one by one, we are discussing about the butterfly wall, check wall, gate wall, globe wall, also the ball wall. So let's move. So, basic definition of the wall. That is, the wall is a device which controls the amount and direction of the fluid flow in a piping system. So, the walls are basically made up of the bronze, brass, iron, or steel alloy. And the basic components of the for construction of the walls that are wall body, disc, seat, bonnet, packing, packing gland, nut, stem, and a fill. So, the types of walls, there are two basic groups which divide the walls, and also there is a special types, that is a relief walls, pressure reducing walls, remote operated walls. So there are two basic groups are stuff walls and check walls. So stuff walls that are used to shut off or partially shut off the fluid flow. So that examples are globe wall, gate wall, plug wall, needle wall, butterfly wall. And the second one, that is a check wall. So it is used to permit flow in only one direction. Example is a ball check wall, swing check wall, lip check wall. And then we discussing the special types, that is a relief wall, pressure reducing wall, remote operated wall. So first one, we can discussing about the stop walls. So first type is that glove wall. So it is the most common type of the stop wall, and that is it is used in steam, air, water, and oil lines. So when disc is attached to wall stem, rest against the seat to stud of the fluid flow. So main advantage of this glove wall, that is used to throttling, and the disadvantage is that to flow the resistance is there. So the glove wall is reducing their efficiency. This is the construction of the glove wall. That is the one fill is attached to the stem, and the fill nut is supporting the fills and the stem. Then there is a gland, the packing nut, bonnet. Also there a union bonnet ring is also there. Then the lock washer is also there. This stem ring is also there. The body, then the wall seat is this. Then dishwasher, and this is the dish. This is the cutaway view of the globe. So this is the globe wall. So we can see this animated video how the globe wall works. So like this, when we turn on this field, give the direction in clockwise or anti-clockwise, and that depends on the setting of this wall. So we can see the wall is open and then close. This is how the globe wall works. Then we discuss about the second stop wall, that is the gate wall. So it is used when there must be straight line flow or fluid where there is a minimum resistance. So gate usually wedge shaped or vertical, this is connected. The advantage is that no flow restrictions is there, and disadvantage is that the poor throttling. Then the construction is of the gate wall is that the fill is attached to same stem. Then here we can use the bonnet brushing. Then the bonnet is there. The gate or disc is this. Then the body. So this is the cutaway view of the gate stop wall. So rising steam type. Then we can see this animated view of how the gate wall works. Like when we can turn the wheels in clockwise or anti-clockwise. So uh, that shows the valve is open or closed and the fluid is likely to flow. Okay, so next one is butterfly valve. So it is used in water, fluid, and ventilation systems. So the advantage is that it is small, lightweighted, and quick acting. And the disadvantage is that it leaks early and only low flow throttle. Then the ball valves that simply it is similar to the butterfly valve that here we use the butterfly valve that this here we using in a butterfly valve. In ball valves we just have to replace the disc by the ball. Normally found in the seawater, scenery, and trim and drain in a hydraulic system. So here we can see the construction of the butterfly valve, that is the handle, and or here we can use the wheel for the moving this butterfly type of disc. Then the body in then the position. This is the butterfly valve construction. Next we can see this the animated video how the butterfly valve works. So uh, then we also discussing about the ball valve. So here we can see the animated video of the ball valve. Okay, like here when we turn give direction to the this handle, then when it is open, then the fluid is get flowed, and when this is off, then we can see in the flow of the fluid is getting stopped. Okay, so like that. Then the second main topic is that is a check valve. In this type of valves, the control direction of the flow operated by the flow of fluid in the pipe. So there are the two types of the check valves that are the swing check valve, lip check valve, ball check valve. So in swing check valve, the disc moves an arc. Okay, in lip check valve, the disc moves up and down direction, and in ball check valve, just ball is located at the end of the stem and the lips to allow the flow. Then here we can see the construction of the swing check valve. Okay, so just the disc is attached and pin is attached and disc nut is attached to the disc to supporting and holding. Then the arm is there. Then we can see the relief valve. So the relief valve says that it is used to protect the piping system from excessive pressure. In piping where the excessive pressure is happening, then the piping system may be blast. So we have to protect this piping system, and where we have to use the valves. So here the relief valve is used. It is open automatically when the fluid pressure becomes too high. The pressure acts against the spring pressure. Then relieving pressure set by the an adjusting screw. Okay, then we discuss about the pressure reducing valve. So it is used automatically provide a steady lower pressure to a system from a higher pressure source. It is used in air, live oil, seawater, and other systems. Then the remote operator valves. So valves that allows operation from a distant section or stations. Uh, then the types of the remote operator valves that are mechanical, hydraulic, motor, solenoid. In mechanical, we just use the rods and gears. In the hydraulic, we use the fluid and a piston setup. In motor, just use the electric or a pneumatic motor. In solenoid, use of coil and core mechanism.